right, so we're moving on to our new unit, which is the exponential unit. Okay, exponential means, what does exponential mean? An exponent is the power. That's right. Exponent is something that has a power, right? But exponential functions, we talked about quadratic functions before, and we know quadratic has a parabola shape, symmetrical. It goes down and then goes up, or it goes up and then goes down, whatever, right? Yeah. Now with exponential, it's something that grows very fast, or grows slow at the beginning and then fast after a few days, few weeks, few years, or whatever. Or it could be decreasing, decay very fast. Okay, so we're talking about exponential. There are different type of functions. There are a lot of time in sciences and in science mostly, right? Mostly in science we see exponential growth and exponential decay. We can also see some in business. Okay. Now first we're going to start with exponent laws. And we're going to explore the exponent laws, and then we're going to move on to finding exponential functions. So let's see first what are our exponent laws. So we're going to start with multiplication law. Okay? So multiplication law says if you have two bases, so just quick review here. In a term, right, this is called the base. And this is called the exponent or the power. Right? So your base is the letter or the number or whatever, that's the base, and then whatever is on top, that's your exponent. Now, as you can see here, I have two terms, and both terms have the same base. Right? Now, and I have a multiplication between them. So I have a to the power of 4 times a to the power of 5. If I'm going to expand this, a to the power of 4 means what?
4 times a.
So a times a times a times a, right? That's what a to the power of 4 means.
Yeah.
So I have a times a times a times a, and then a to the power of 5, that's a multiplied by itself 5 times, right? And that multiplication here that you see here in the middle belongs to this multiplication. Okay? So I have a to the power of 4 times a to the power of 5. So what do I have here at the end? If you look at this, I have 9 a's multiplied together. Okay? So I can simplify this and write it as a to the power of 9. All right? Now, let's try this one in the expanded form. So you're going to see a pattern. Okay? So if I write this in expanded form, I have a times a, right? That's my a squared. Then multiplied by a times a times a times a. A to the power of 6. How about the next one? So I have a times a times a times a times another one. And then multiplied by just a, right? If it doesn't have an exponent, it's an exponent 1. How many a's do I have here?
6.
Have you noticed any pattern so far? The exponents are added. Okay, so let's just write this one. So if I look at this, I have 1, 2, 3, 4, 5, 6, and then 2 other ones, so that's 8. Right? I don't really have to do that every single time, right? You see that no matter what numbers I have, right? If I expanded it, it ends up being the base and to the power of the sum of your exponent. Okay? So it ends up being, instead of writing it all in expanded format, it ends up being keeping the base the same and adding my exponent. So I have, in this case, 4 plus 3, which is 7. Right? Even if you do it the expanded format, you're going to get the same answer. Right? So if I look at this one, the one above it, a to the power of 6 times a to the power of 2, I keep my base, which is a, add 6 plus 2 gives me 8, right? The previous one, I keep the base the same, a, 5 plus 1 gives me 6, right? So I don't have to actually write it in expanded format because it takes a long time to do that. So here's the rule with the exponent law. Now, can you do that with different bases?
No.
No, it has to be the same base. Okay? So the rule says you're going to keep the like base, and then you're going to add the exponent. Okay? So if I have, let's say, a to the power of m times a to the power of n, I keep the base, so I keep the a, and then I add the exponent m plus n. Are we good with that? All right. Now what happens with division? So if we're going to move to the division law. Okay? So the first one is already done for us. So a to the power of 5 divided by a to the power of 4. So we have a times a times a times a 5 times divided by a times a times a times a. So with division, you can simplify, right? So you can eliminate. So I eliminate 1, 2, 3, 4. What do I have left?
1.
Just a. Just a to the power of 1. Okay? Now, how about the next one? So I have a times a times a times a over a times a. So what do you see here? This cancels. This cancels. I'll be left with a squared. What do you think is happening here? You're subtracting the exponent. Correct. So with division law, if I have the same base and I'm dividing, I subtract the exponent. Okay? Again, keep the base the same. You don't change the base. You subtract the exponent. So what do you think the answer for this one is going to be? A to the power of 4, because what I have is 5 minus 1, which is 4. Okay, how about the next one? It's 4 again. Okay, and then for this one, it's going to be just okay. So with the division law, again, we're going to keep the like base. And then you're going to subtract the exponent. All right? So if I have am, you can write it like this, divided by a to the power of n, or it could be like so. Okay, it doesn't matter which way it's written. Okay, it's going to be a to the power of m minus n. Again, as long as your base is the same, you can always do it. Any questions about this? this case, I only have one base. It's a to the power of 4 to the power of 5. Okay? Which means that I have a to the power of 4 multiplied by itself 5 times. So I have a to the power of 4 times 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 another a to the power of 4. Right? What did we learn about why I have multiplication? So if I add 4 plus 4 plus 4 plus 4 plus 4, that's going to give me 20, right? So that's a to the power of 20. Now, a to the power of 2 times a to the power of 2 times a to the power of 2. What is that? A to the power of 6. A to the power of 5 times a to the power of 5. What is that? A10. Now, what are we doing here? Multiplying. That's right. We're multiplying the exponent. Okay? So whenever I have power to the power, I keep the base, nothing happens to the base, and then I multiply the exponent. Any questions about this? So we're going to keep the base and then we're going to multiply. Are we good? Questions? Okay, you can do the first few, right? So what would that be? X to the power of 11, because I'm adding the exponent. Okay, next one. 8, because you're multiplying, right? I have power to the power. This one? 6, because I'm subtracting. So 9 take away 3. All right, how about the next one? What do I do? Add which ones?
The exponents.
So all together?
No, each one. What's each base?
So I have x cubed.
X
I can add the exponent for the x's, right? And then x1. Because they have the same base, I can keep that base and then add these exponents. And for the y, I'll do the same thing. I have a multiplication between the two brackets. You see that? So I have 2 plus 5. So that gives me x to the power of 4, y to the power of 7. Okay? So remember that we can only do that with the same base. How about the next one?
Not the same, no.
Just the x, okay?
Just the X,
So the x is gonna,
10
x10, because I'm gonna add these exponents,
and X.
and then just y3, it doesn't change. Y does not change, it stays as y to the power of 3.
So in this case, you can multiply X and Y too?
No, because
X.
this is all multiplication. This is the same thing as writing this. We are not, it's not, there's no plus here. If there was a plus here, then yes, what you were saying. But there's no plus, it's all multiplication. All right. For the next one, I personally like fractions more than division like this, so I personally like to write it as 2x7y4 over x6y. I see it better that way. Okay? Up to you guys, you don't have to write it this way. I personally like it in the fraction format. So what can you tell me about this?
Subtract.
Subtract the exponent for the x, yeah? How about the 2?
Yeah.
Stays there. There's nothing else to simplify it with. And then this is going to be subtraction, so that's going to be to the power of 1, or I don't have to write it. And then y is to the power of 3. Sure. Questions? Okay. So we're moving on to the little bit more complicated stuff, okay, which is the power of a product law. So what happens if I have more than one thing in that bracket? You know how we did like x to the power of 3 to the power of 2, right? We know that we're going to multiply the exponent. There's only one letter, multiply the exponent. But what if I have more than one letter or more than one variable inside my bracket? What's going to happen?
To use each one? Exponent each.
Yeah.
Yeah, each one.
So each term is going to be to the power of 2. Okay? Each letter, so what's going to happen here, we call that the distributive property, right? And then what's going to happen, that 2, it's going to be multiplied by both exponents. Okay? So that's going to be x to the power of 8, and then y to the power of 6. How about if I have this? How about if I have 4x squared y4 to the power of 2?
Because it's like three terms.
So we have three,
Not terms.
not terms, yes.
Not terms.
Three things, three, whatever you want to call them. They're not terms.
Three
Because
elements.
what terms means like
Yeah,
when you have a
there
plus
is
and a minus.
There is a sign between it. But
Yeah.
three elements.
Yeah.
Different three elements. And
Yeah.
we have exponent for numbers, specific numbers. So we spread this exponent.
Distribute.
Distribute this exponent to each element.
Yes.
Each things.
Yes. So don't forget the 4 as well.
Yeah.
Okay? So you see that the 4 has an exponent 1. A lot of people miss that. Okay? They multiply the exponent with that for the variable, but they miss the number. So for you to visualize this, put a 1 as an exponent for that number. Okay? So if you look at this, that's going to be 4 to the power of 2, right? X to the power of 4, y to the power of 8. Okay? So that 2 is going to multiply with each exponent, including the coefficient. Okay? So that can be simplified as 16x4, y8. Okay? Are we okay with this? How How about the division? So we call that the power of a quotient law. Same idea, quotient law. Okay, same idea. We distribute the exponent to each letter or to each element. Okay, so what happened here is I multiply that 2 by, so I have x8 over y6, or divided by y6, whatever is easier for you to write. Okay? Are we okay with this? All right. How about when I have sum or difference? When I have a term subtracted by another term to the power of 2.
Units.
Uh-huh.
We have two brackets
Uh-huh.
behind each other, so we will consider each terms like we will do like what
Four.
distribute foil.
We have to
foil.
Okay, so whenever you have a subtraction or an addition between the terms, you cannot just distribute like this. You can't just do whatever we were doing for the product and the quotient. Okay? We have to write this twice, as we learned in previous units, and we have to FOIL. Okay? We can't just simply put the square in. Are we okay with that? So let's FOIL this. x4 times x to the power of 4. What would that give me? Do you guys agree with that? So I have x to the power of 4 times x to the power of 4. Yes? What do I have here? I have the same base, and they're multiplied. What do I do with the exponent? Add them. Right? So that gives me x8. So that's when I do x4 times x to the power of 4. Then I have to do x to the power of 4 times negative y squared. What would that give me? Negative x4 y squared. I can't add these. I can't subtract these. What's up? Y cubed. Yeah, I messed it up. Okay, thank you. All right, next. So I subtract. Can I write x4 y cubed? Okay. Then I have negative times negative, that gives me positive. And then y cubed times y cubed, y6, right? Because I'm adding the exponent. So that simplifies because I have my like terms here. So that gives me x8 minus 2 x4 y cubed plus y to the power 6. Okay? So when it comes to the power, we have to do the FOIL. Okay? When it comes to subtraction and addition. Okay? So I'm going to leave you guys to do the examples on the side. The first one is similar to what we just did, so you don't have to do that one. We just did that one. You can do the rest.